Hello everyone, welcome to today's class. This is Simon taking you through circle theorems, and these are examination questions for this question paper 1. Now let's take a quick look through the circle theorems. We have tangents. A tangent is a line that can intersect a circle in 3 possible ways. It can be a diameter, that is the one that passes through the center of the circle and connecting 2 points on the circumference of the circle. Then we can have a chord. It connects 2 points on the circumference of a circle but doesn't pass through the center. And then we have a tangent here which meets the circle at only 1 point. Okay, then in here we can form now tangent properties. Okay, tangent properties. So tangent property number 1 is that when you draw a circle, the angle between the tangent and the radius or the diameter will always be a right angle or 90 degrees. Okay, then tangent property number 2, if you have 2 tangents which are intersecting outside the circle, these 2 tangents are equal in length. So AP here is equal to BP. Okay, then next can now go to chords and segments. A chord is a straight line joining 2 points on the circumference of a circle. Okay, and then a chord divides a circle into 2 segments. There is a major segment and then the minor segment. Now symmetry property number 1 for chords. Any chord that you draw on a circle, the distance from the center of the circle will always bisect that chord. Okay, why is it so? It is because this is an isosceles triangle. Triangle OAB is an isosceles triangle. So if this length here is equal to this length, automatically when you divide this into 2, this has to be equal to that. Okay. Next, symmetry properties of chords 2. If we have 2 chords of the same length, like AB here, AB, and then CD, these 2 are going to be the same distance from the center of the circle. Okay, now theorem number 1. The angle at the center is always twice the angle at the circumference. So if I have a point here and then I have a point here, then it forms an angle at the center here. Then again at the same point, I draw chords that are connecting to the circumference of the circle and also connecting to this one here. It should be known that the angle at the center is twice the angle at the circumference. Theorem number 2. Angle in the semicircle is always 90 degrees. In other words, the angle subtended by the diameter at the circumference of the circle is 90 degrees. Remember the previous one, we have said that the angle at the center is twice angle at the circumference. So you can see that this is 180 degrees here, and then if you divide this by 2, the angle at the circumference here is 90. Okay, this one is just an application of the previous one. So angle in the semicircle is always a right angle. Theorem number 3. Opposite angles of a cyclic quadrilateral add up to 180. So I have an angle here, then another one here. When we add them, they give us 180. The vertices of this quadrilateral are all on the circumference of the circle. That's why we call it the cyclic quadrilateral. Okay. Next, angles from the same arc in the same segment are always equal. If we look at 2 points, I have a point here and then another point here. Then I draw chords from them then onto the circumference of the circle. I also draw another chord here connecting here, then we come here, and then also another one here. It is known that all of those angles that are formed are equal because they are in the same segment. So angles in the same segment by the same arc are equal. Now let's go to our examination questions. So question number 1 is here. They are saying that KL and M are points on the circle. KS is a tangent to the circle at K. KM is a diameter and triangle KLM is isosceles. Find the value of Z. The value of Z. Now this angle here, KLM, this one here is 90 degrees. Angle KLM is equal to 90 degrees because this is angle in the semicircle. Angle in the semicircle, like we have seen, is always a right angle, 90 degrees. So having seen this one as 90 degrees, then that means this angle here is equal to this angle here because this is isosceles. When you look at this side here, opposite to this angle, and also this one here. So since these two sides are equal, that means even the angles here are equal. Okay. So that means, of course, that one is going to be 45 because you have the 2x, then plus the 90, then they will give you 180 degrees. So x here is going to be equal to 180 minus 90, which will give us 90, then divide by 2. This one will give us 45. Okay. So having gotten this one here as 45, then z is going to be equal to 90 degrees minus the 45. Okay, because angle between the radius and the tangent is always 90 degrees. So I'll get 90 here, then minus the one that I've gotten here. So this will give me 45. So I'll just come here and write my answer as 45 degrees. Okay, so these diagrams, they always put not to scale. So meaning that when you put your protractor to measure, the angle you're going to get is not necessarily what is written there. That's what it means. It's not to scale. Okay. Then Roman 2, they are saying that AT is a tangent to the circle at A. Okay. And then they want us to find the value of x. Now, in the circle theorems that I've shown you, there is one that I haven't talked about. It is called the alternate segment theorem. In the alternate segment theorem, you look at the tangent here. I have a circle, then there is a tangent, then there is a triangle formed. And the angle between this tangent and this chord here, this angle here will always be equal to this other angle which is opposite to this segment here. It will always be equal. So this simply implies that if we have 58 here, identify the segment within which it lies, and then you look out for the angle that is opposite to that segment. So that means that one is going to be 58. Okay, so we are going to have 58 degrees here, and then they want us to find the value of x. So the value of x is here. We are going to use the exterior angle property of a triangle. So this 27 plus this one here will give us the x here. Okay, when you have a triangle like this angle here, A, then plus B, will give you the angle C here. Okay, the proof is this one. If this is D, and then we have A plus B plus D is equal to 180, because these are angles in a triangle, then also C plus D is equal to 180. You see? So I can equate these two because this is 180 and this is 180. So that means I can have A plus B plus D is equal to C plus D. You see that? So D can go. Do you see that A plus B is equal to C? All right. So the exterior angle property, the two interior opposite angles, the sum of the two interior opposite angles is equivalent to the exterior angle. Or you can actually first find this one here. It will be 180, then minus that 58, and then add it to the 27. You see that? So what you get, now again, you are going to say 180 minus that angle, because these are angles on a straight line. So without wasting time with all of that, all you need to do is to say that exterior angle, you use that exterior angle property. So x here is going to be equal to 180 which is going to be 58, then plus the 27. And this one is going to give us 85 degrees. As simple as that. Next, F, G, H, and J are points on the circle. EFG is a straight line parallel to JH. Find the value of Y. Now, since these are parallel lines, okay, this angle here will be equal to this angle here. Okay, we have something like a Z. Those are alternate angles, you see? Or we can look at this one here. This one here is equal to that. So this is 108, even this one will be 108. So I'm going to write this one here as 108 degrees. Then Y plus 108 degrees is going to be equal to 180 because opposite angles in a cyclic quadrilateral add up to 180 degrees. So that means our Y is going to be equal to 180, then minus 108, which actually gives us a 72. Part B, we are given this diagram here and they are saying that A, B, C, D are points on the circle with center O. M is the midpoint of AB and N is the midpoint of CD. OM is equal to ON. You remember the tangent property, I mean the symmetry of chords property 2, where we said that if two chords are of the same length, okay, then they are the same distance from the center of the circle, okay? So if they want us to prove that these ones are congruent triangles have the same lengths, okay? They have all the corresponding lengths are equal, and even the corresponding angles are also equal. Now, first of all, OA is a radius. OB is also a radius. When you look at OD is a radius. OC is a radius. So I will begin from there. So I will look at all the sides. Are they equal? Okay. So I'm going to write here that OA is equal to OB is equal to OC and then OD. OC, then OD, which is actually the radius of the circle. Okay. Then what else? We have, since OM, okay, since OM is equal to ON, so write this, since OM is equal to ON, okay, then CD is equal to AB. Those two chords are the same length, okay? So we have seen this side is equal to this side. This side is equal to that side. Now this side here is equal to this side here. So all the corresponding sides are equal. So that means these shapes are congruent. So I've used the criterion because there is a criterion you are supposed to put down. Have you used side, side, side? Have you used side, angle, side? Have you used angle, side, angle? Or RHS, where you are having a right angle triangle? So for this case, we have used side, side, side. So we will say that triangle OAB is congruent to triangle OCD, and then we conclude that criterion used is side, 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 just like that. Question 3. A, B, C, and D are points on the circle center O. EF is a tangent to the circle at D. Angle ADE is equal to 42 degrees and angle COD is equal to 162 degrees. Find the following angles, giving reasons for each of your answers. Okay. So the geometrical reasons that we are supposed to give here are the circle properties and theorems. Okay, so find angle x. Angle x here, if you look at this point here, D, and you look at point C, then you look at this angle here at the center, 162. Then you also look at point D. Then you look at this angle x formed. Don't you think that this is angle at the center and then this is angle at the circumference? Okay, so that means our x is going to be a half of this one here, a half of 162. So x is going to be a half of 162, which is 81 degrees. So the reason I'm going to state here is that angle at the center, is twice angle at the circumference. Then next, angle y. Let's look at y here. Now angle y here, when you look at the segment within which it lies, and you look at the opposite angle, because this is a triangle, this one here formed. Now this angle here, x here, opposite to this segment within which y lies, that's what we call the alternate segment theorem. So x is going to be equal to y. So I will say y is equal to 81 degrees, and then the reason is going to be alternate segment theorem. Simple as that. Alternate segment theorem. Then next, angle z. How do we get angle z? We are going to first find this angle here. Now I want you to look at this. This angle here is opposite to this z here. And when you look at this A is on the circumference, D is on the circumference, C is on the circumference, and B, that is a cyclic quadrilateral. That means if we get this angle here, then we shall be in position to get Z, because these are opposite angles in a cyclic quadrilateral. Okay, so that means we are going to first find this small angle here and also this one. They are the same, because this is an isosceles triangle. OA and OD are the same. Okay, so since we have even gotten the y, the angle between the radius and the tangent is 90 degrees, right? So we shall say 90 minus y, which y we got as 81. This one gives us 9 degrees. So here we shall have 9 degrees. You see that? Then of course y here is 81. So now let's find this other angle here. So this other angle is going to be, let me write it now here, 180 minus, we have the 42 there. Actually, let me just say 180 minus 42 minus the 81. Okay, minus the 81. So altogether, I would be getting this angle here, the whole of it. Okay, angles on a straight line, remember, add up to 180. Okay, so I subtract this and then this one, then I would be getting the one that is remaining here. So this one will give us 57. Okay, then after getting that 57, Z is going to be equal to 180 minus 57. Which theorem are we using here? Opposite angles in a cyclic quadrilateral add up to 180 degrees. We are going to have 180 minus 57, that is 123. Yes, 123 degrees. So Z will be 123 degrees. And then the reasons that I'm going to put here, I used, for me to get the 57 here, it is for angles on a straight line. So I will say angles on a straight line, angles on a straight line add up to 180. Angles on a straight line add up to 180 degrees. And then the other one we have used is opposite angles on a cyclic quadrilateral. Okay, quadrilateral add up to 180 degrees. So that is that. Then question 4, part A, they're saying that points R and S lie on a circle with diameter PQ. RQ is parallel to PC. Angle RPQ is 58 degrees. Find the value of X giving a geometrical reason for each stage of your working. Now, this one being a diameter, that means the angle that is here is 90 degrees. So, meaning for us to get the angle that is here, we just need the angle that we add on 58 to make 90, because already this is 90 degrees. So that means these two angles must also add up to 90 degrees such that we get 180. Okay, so we shall say that angle PRQ, okay, PRQ, this P, then R, then Q, this is the R here, it is going to be equal to 90 degrees. So it's equal to 90 degrees. And then my reason is going to be angle in the semicircle, is always 90 degrees. Then after that, we are looking for, let's check the other angle here. When I get this angle here, it is the same as this one X here. Okay, do you see that this one is parallel? This line here is parallel to this one. So using our Z, this angle is equal to that. So this one here will be equivalent to that. You see that? So that means we shall get angle RQP. So angle RQP is going to be equal to 180, then minus 90, then plus the 58. Okay, and this one will give us 32 degrees. Okay, then after that we shall say that X is now going to be equal to that 32. What is going to be the reason here? Alternate angles. Alternate angles are equal. So I'll write my X here as 32 degrees. So that is that. Then question 4b, points A, B, and C lie on a circle, center O. Angle AOC is equal to 142 degrees. Find the value of Y. Okay, now people can confuse these two, thinking that this one here is the angle at the center, therefore this is the angle at the circumference. No, if the angle at the circumference, the arc that forms it, okay, if the arc is like this here, then that means the angle at the center is also going to look like it. You see that? This one here. Remember, we have this. Sorry, if this is the angle here, are you seeing how I'm doing this? The arc here, like this, then the angle here is also the same. So meaning that here we are also going to have the same thing, that this angle Y, the angle at the center is this one here. And you know that angles at a point sum up to 100 and what? And 80. I mean 360 degrees. So I would say reflex angle AOC is equivalent to 360. Okay, this is the reflex I'm talking about. 360 degrees, then minus 142 degrees. So this one is going to give us 218 degrees. You see that? So what is my geometrical reason? My geometrical reason here is that angles at a point add up to 360 degrees. You see that? So then how do we get our y? Remember, angle at the center is twice angle at the circumference. So this is 218. So this being angle at the center, it is twice this one here. So I will say 2y is equal to the 218. So meaning y is going to be 218 divided by 2, and my answer is going to be 109. My reason here is angle at the center. Angle at the center is twice, okay, angle at the circumference. I'm going to be writing all of these geometrical reasons, okay, because sometimes they ask them like you saw in the previous question. Question 5, part A, B, C, and D are points on the circle center O. Angle COD is 124 and angle BCO is 35 degrees. Roman 1, work out angle CBD. Give a geometrical reason for your answer. Angle CBD is equal to what? Okay, now let's check this one here. If this is 124, if this one here is 124, we are looking for angle CBD. CBD. So this is the angle here. Now, you can see that this is angle at the center and this is angle at the circumference. So what do you think CBD is? A half of 124. So angle CBD is going to be equal to a half of 124, and that one will give us 62. So the geometrical reason is going to be angle at the center. Angle at the center is twice angle at the circumference. Is twice angle at the circumference, just like that. Okay, so I can even write this 62 here. Then next, Roman 2, they are saying that work out angle BAD. Give a geometrical reason for each step you are for each step of your working. BAD. So where is our BAD? B, then AD. So that means we are looking at A here. They want us to find that angle. Now, do you realize that if I get this angle fully, then and A, these are angles, opposite angles on a cyclic quadrilateral, because A, B, C, and D are all on the circumference of the circle. Not so? Okay. Now, let us first find this small angle here, and then this one here. They are the same because this is an isosceles triangle. This is OD, which is the radius, and also OC here, which is the radius. So we are going to say that angle OCD, let me say angle OCD is going to be equal to 180 minus 124. Then I'll divide by 2 because these two angles are the same, this one and this one. Okay, x plus x then plus 124 equate to 180. So to get x, it will be that 124 subtracted from 180, then we divide by 2. Okay, and this one will give us, when we subtract this one, it will give us 56. Okay, so 56 divided by 2, that one will give us 28. Okay, so I'll begin my geometrical reasons by saying there is an isosceles triangle. Okay, isosceles triangle. That's why I have been in a position to get that angle OCD, which I've called X, to be 28. Okay. Then how do we get this angle BAD? So angle BAD is going to be equal to 180. Then I subtract the opposite angle 35 plus the X I've gotten. Okay. 35 then plus the 28 here. So when we put in the calculator here, what do we get? 180 minus 35 added to 28. This one gives us 117. So I'll write 117 here. And then my other geometrical reason that I'm going to put here, how I got this one, is that opposite angles in a cyclic quadrilateral. In a cyclic quadrilateral add up to 180 degrees. You can even say a supplementary, because supplementary angles, that's a pair which adds to 180 degrees. Then part B, P, Q, R, and S are points on a circle. Center O. QS is a diameter. Angle PRS is equal to 42 degrees. Then PQ is 5.9 degrees. Centimeters. Calculate the circumference of the circle. So circumference of the circle is pi d. So we need to find this d, the diameter. Okay. Now, we know that angle in a semicircle is always 90 degrees. Okay. Because this is the diameter, it passes through the center of the circle. So this is 90 degrees. And also, angles in the same segment are always equal. So when I look at S and P here, then this angle 42 is the same as this other one here. Angles in the same segment are equal. So meaning I'm going to have this one here as 42 degrees. You see that? So since I know this length here and the angle here, and this is a right angled triangle, then we can use SOHCAHTOA, okay, to find this hypotenuse here. You get it? Okay, now let's start. So I will say, first of all, that angle QPS is equal to 90 degrees. Okay, QPS here, 90 degrees. And then Y, then I will say angle in semicircle, angle in the semicircle is always equal to 91 degrees. Then from there, using SOHCAHTOA, okay, then we shall have, relative to this angle here, this is the adjacent, this is the hypotenuse. Okay, so adjacent and hypotenuse are connected by the cosine. So I'll have cosine of 42 degrees is equivalent to the adjacent, which is 5.9, then divide by the hypotenuse. The hypotenuse is that SQ, which is the diameter. Okay, so how can we get SQ? We cross multiply and then we divide through by cosine of 42. So SQ is going to be equal to 5.9 divided by the cosine of 42 degrees. You see? So this is our diameter. And then after finding the diameter, then we can find the circumference of the circle. Circumference of the circle is equal to pi d. So I'll get pi, then times the d I've gotten as 5.9 out of the cosine of 42 degrees. Pi, then times 5.9 out of cosine of 42. The calculator has to be in degrees, okay? So this one gives us 24.9 and the rest of those figures, but I'm going to write my answer to 3 significant figures. So that is 24.9. So I write 24.9. Question 6 part A. A, B, and P are points on a circle. Center O and angle OBA is equal to 38. Find angle APB. APB, this angle here. Now we need to find the angle at the center here. This one here being equal to this, because the two are radii, then this angle here is also 38. Okay, 38 degrees. So meaning angle at the center, AOB, angle AOB, angle AOB is going to be equal to 180 minus 2 times the 38. Okay, so what do we get here? 180 minus 2 times 38. This one gives us 104. So 104, sorry, this is 104 degrees. So if we have this as 104 degrees, then the angle APB, by the way, angle at the circumference, it can be like this here, directly here, like that. It can be here. Okay, it can, they can bring it passing through the center like this. Okay, all of these angles are equal because they are angles in the what? In the same segment. So this will be the twice x. So this one is angle at the circumference. You see that? So angle APB is going to be a half of this 104, which is going to give us 52 degrees. And then part B, we are given the diagram here, and they are saying CDEF is a cyclic quadrilateral and FC is equal to FE. TU is a tangent to the circle at C, and angle TCF is equal to 50 degrees. Find Roman 1 EFC. So EFC. Angle EFC, we are going to start from here. This is 100, this is 50. They want EFC. Where is EFC? EFC. So it has to be here. Okay. Now, we are going to start with this one here. Look at the segment within this lies. Then that means that when you look at the angle opposite to it, it is this one here, which is 50 degrees. Okay. So I'll put a 50 here. Now, since this length here is equal to this one, that means even this one here is 50 degrees. You see that? Now, the angle EFC, it is going to be a matter of subtracting the sum of these two from 180 because that is a triangle. So angle, I'll begin by saying angle TCF. Angle TCF, this 50, is equivalent to angle CEF. Okay? Angle CEF, which is here. And this is 50 degrees. Here I'm using alternate segment theorem. Alternate segment theorem. You see that? So, therefore, angle EFC is equivalent to 180 degrees, then minus the sum of these two. Of course, 50 plus 50, you get 100. So subtracted from 180, you get 80 degrees. You see that? Okay. Then the next one, angle CDE. Angle CDE. CDE. Do you realize that since this one is a cyclic quadrilateral, they even told us here. So this angle here is opposite to this one. That means to get angle CDE, I'm just going to say angle CDE is equivalent to 180 minus this one. I've just gotten EFC. So minus the 80 we have gotten. So meaning we get 100 degrees there, because opposite angles in a cyclic quadrilateral add up to 180 degrees. And then lastly, for this paper, we are given this diagram points. A, B, C, D, and E lie on a circle. PAQ is a tangent to the circle at A and EC is equal to EB. Angle ECB is equal to 80 degrees and angle ABE is equal to 40 degrees. Find the values of W, of V, W, X, Y, and Z. Okay. Now, there are a lot of circle theorems involved in here. So if EC here is equal to EB, the EC here is equal to this one. Don't you think this is an isosceles triangle? So this is equal to that. So the base angles of an isosceles triangle are always equal. So W has to be equal to 80 degrees, right? So W is equal to 80 degrees. Okay. Then next, if we can check X here and then the 40, look at this angle being formed here like this, and you also come to the same point E, you look at this other one here formed, and then again to this other point here. So these two angles, this one here and this one, we call them angles in the same segment. So X is going to be equal to 40. X is equal to 40 because those are angles in the same segment. Okay, that is that. Then let's look at which other one is easier to get again. So let me actually put a 40 here for this, and then W, I put an 80 here. Okay, now do you also see that A, B, C, D is a cyclic quadrilateral? So what does this mean? Is that this angle here, the whole of it here, plus the Z here, they will give us 180, because opposite angles in a cyclic quadrilateral add up to 180 degrees. So we shall say that our Z here, Z is going to be equal to 180 minus the sum of these two angles, 40 plus the 80. 40 plus 80 is 120. So subtracted from 180, this one actually gives us a 60 degrees. So Z is 60 degrees. You see that? Okay. Then what is remaining? We have Y and V. Let's look at V. Look at this one here, PAQ being a tangent, and look at the angle it forms with this chord. Okay, if you look at the segment within which this V lies, and you check A, E, and D, which is a triangle, then that means that we look at the angle that is opposite to this segment here. This angle which you get here is exactly the same as the one that is formed between this chord and the tangent. So that is what we call alternate segment theorem. Okay, so V has to be equal to 40. V would be equivalent to 40. And then what is our Y here? Our Y here, E, A, B, C. That is another cyclic quadrilateral. Okay, so meaning 80 here is opposite to this Y, the whole of this and this one here. So Y will be equivalent to 180. Then we subtract 180, we subtract the 80. So what will that be? 180 minus the 80. Of course, that has to be 100. So Y is 100. Then part B. In the diagram, KL and M lie on the circle center O. Angle KML is equal to 2x and reflex angle KOL is equal to 11x. Find the value of x. They said reflex angle KOL that is the one here. It is 11x. And then they say that angle KML, this one here, is twice x. Now this is angle at the circumference. Then there is angle at the center here, which is twice this one. So we shall have 2 times the 2x here. Isn't that 4x? Now these two are angles at the center, which add up to 100 and what? I mean 360 degrees. So we shall have 11x, then plus 2 times 2x, we get 4x, right? Then it's equal to 360 degrees. So this is 15x, which is equal to 360 degrees. X here is going to be 360 divided by the 15. What do we get? 360 divided by 15, 24. So x is equal to 24. So this has been it for this first question paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.